Hello again and welcome back to the SOS session on rounding and decimals. So we're going to continue now looking at more towards Year 4 and Upper Key Stage 2. And we're going to start off with rounding. So this should have started in Year 3 and 4 as you build up to round any whole number to the nearest 10, 100, 1,000. So rounding 185 to the nearest 10, 100 or 1,000, it would be a sort of a typical question. Children's experience with number lines is really important early on with this. So the notion that 27 is closer to 30 than it is to 20 before we move on to any other strategies alongside that. Okay, so obviously built on the number line work as well, there is another strategy that you can use to teach rounding using place value. So say for example you're rounding 185 to the nearest 10. I would say to the children to circle the digit in the tens column, which in this case is 8, then underline the digit in the column next door, which will determine whether the tens move up or move down. In this case, the number is 5. So you may have heard the poem 5 to the sky, 4 to the floor, or which helps the sort of children remember a little bit. So in this case, it's 5, so we round it up. So, and we put our 0 in there as a placeholder. And in this case, we round up the 8 to 9, and then we pop that 1, which does not change because it's in the 100 column. Okay, so there we have 185 to the nearest 10. Moving on to 100, if we were rounding to the nearest hundreds, I would ask the children to circle the digit in the hundreds column, so check their understanding, and then underline the digit in the next column, which will determine whether it rounds up or rounds down. In this case, it's 8, so we pop the 0 in as a placeholder beneath the tens and the units because we're going to look for a number in the, if we're rounding to the nearest 100, our final answer will be a multiple of 100. So we can pop those zeros in straight away. Because it is 8, it's greater than 5, and we round this 1 digit up to 2. So 185 to the nearest 100 is 200. Again, in this case, to thousands, you look at thousands and you look at the hundreds. In this case, it's 1, you round down, so it would just be 0. Okay. So let's just take a look at the progression. So in Year 4, you would start by introducing decimals with 1 decimal place to the nearest whole number, so 1.7 to the nearest whole number. Then following on to Year 5, you would be moving on to 2 decimal places. So for example, 3.81 to the nearest whole number to 1 dp, so getting children familiar with that sort of language and those abbreviations there. And 0.45 to the nearest whole number to 1 dp. Okay. Now, think carefully about those misconception opportunities as well. So, you know, is there a case they might treat it as a whole number, and they might find it difficult when they're moving up into a whole number? Also, misconception opportunity for 9.99. So when more than one of the digits change. So let's just look at that one. So in this case, if you are rounding 9.99 to the nearest unit or nearest whole one, you can't. The only digits that you can have in one column are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you go next door, it's a 9 there. So you're going to round up that following 9 because the tenths column is a 9. If you round that 9 that's in the ones column up, you can't have 10 in the ones column. So it's going to go back to 0 and you're going to end up with 1 in the tens column. So this is what we call column value, and it's a notion, the understanding that children understand what comes after 9 or 99 or 999 and how those digits change and how those columns affect it and what digits can exist in each column without before it has to move over to the next column. A really nice resource to use for this, you might have seen, is a place value flip chart. So you can get these very colourful flip charts where you can physically add the tens digit. So you could make 9.99 on your place value flip chart, and then the children could physically see that there are no more digits if you add one more to 9, and therefore you will have to return to 0 and the next column will become a 1. Therefore, your answer being 10. Okay. Okay, now let's look at that a little bit more closely at rounding those decimals. So 1.7 to the nearest 1 or whole number. You look to the next door, the next column, which happens to be the tenths. 7 is greater than 5, therefore you would round the 1 in the units column up to 2, and you've got your 0 there as a placeholder, because it's all going to just be, if it rounded to the nearest unit, it will just be a unit answer. And similarly in this case, 3.81, let me just take my pen up, and you've got 8 in the tenths column. If you're rounding to the nearest tenth, circle the 10th digit, underline the 1 next door that determines whether it moves up or moves down. In this case, it's going to remain the same. What changes, what stays the same is a really good question to ask the children to really secure their understanding of this procedure. So 8 remains the same, and 3 remains the same. There we have it. 3.81 to the nearest tenth is 3.80. Okay. And here we have 0.45. So if we're wanting to round that to the nearest tenth, you circle the digit in the tenths column and the one next door, which happens to be the hundredth. In this case, it's the 5, so 5 to the sky, 4 to the floor. Anything greater than 5, anything above 5 or 5 itself will need to be rounding this digit up, in which case it is this case. So 4 tenths will then become 5 tenths, and then you'll pop your 0 in as a placeholder. Okay, you could put your 0 in, but it doesn't really change the value of the overall number. So the answer is 0.5. Okay. And then going back to this number here, which I mentioned earlier, you're rounding to the nearest units. If you've used the column value, you could use that flip chart. They have to look next door to see that actually, in this case, the tenths digit is greater than 5. So this digit will have to go up 1 more unit. Now we can't have 10 units, so it goes back to 0, and we have 1 tenth. Okay, and then you could pop your zeros in as a placeholder, or you could just leave it as 10. Okay, if you wanted to round that to the nearest unit. Bit of a misconception there, because if you're rounding to the nearest unit, but you've ended up with a 2-digit number, but that is in fact correct. So more on misconceptions. There's a website here that I've just placed underneath for you to find out any misconceptions if you're about to teach a lesson on decimals or fractions. Again, another misconception that children tend to come up with fractions is that 3/4 would correspond to 0.34, or you might see children saying, of course, 4.79 is greater than 4.8 because 79 is more than 8, which we've already talked about a little bit in the last part. And decimals get smaller and smaller the further you go to the right of the decimal point. That's only 0.431, which is smaller than 0.4. Okay, so lots of things to look out there, but hopefully if you've seen part 1, you'll have some ideas about how you can take that back and really challenge those misconceptions. Okay, looking on to equivalence. So in year 5, children apply their understanding of decimals, fractions, decimals and fractions as they learn percentages, and they learn that they can be equivalent, and that percent means out of 100. So coming back to what I mentioned in part 1, here we are with back to the deans and following what the children already know. So just building up those steps. They would have come into contact with deans in the context of hundreds, tens and ones, and then obviously when you've introduced decimals, hopefully in year 3, they've looked at it being represented as 0.01. These are tenths, and this is a whole, what they used to know as 100 square is a whole 1. So then when you're introducing fractions, you can pop those fractions in. And the good thing about fractions is that the language tells it all. So 1/10, that language is actually 1 over 10. 1/100th is actually 1 over 100. Now, when you move on to fractions like this, I would ask the child to split what they know to be the 1 into 2 halves physically. So just drawing a line there or separating the hands-on deans. And then you can see quite clearly that there's 2 parts to that whole one, and half of it here is 1, 2, 3, 4, 5 tenths. Okay, which is why a half is 5 tenths. Okay, and you can see that nice and visually. Similarly, with quarters, if you take that whole one and you divide it into 4 quarters, you would end up with this part here that I've shaded in green. That would be a quarter, which if you count all the squares is 25 hundredths. Or we could say that's 2 tenths because there are 10 hundredths in a tenth. So that's 2 tenths and 5 hundredths. So we write it as 0.25 for a quarter. So with this resource in mind and this visual here, see if you can find the decimal equivalents for each of the fractions. I'll just have a pause and have a go. Okay, and then here, hopefully you've had a chance to finish all of those. And here are the answers. So you've got a half, which is 0.5 tenths, quarter, which is 0.25, which we've just explained. 3 quarters is going to be a quarter plus a quarter plus a quarter, hence 0.75. And obviously 1/10. We've labelled those on the deans, and the children are quite clear about those, hopefully by this stage. And changing the numerator, we're going to end up with 3 tenths, which is 0.3, and 1/5 is 0.2. Now let me just show you another way you could demonstrate that with a resource. I'll show you that in a couple more slides time, because sometimes that last one, 1/5 being 0.2, is a little bit tricky for some children. So if children are more familiar with Numicon as opposed to deans, these are excellent because a baseboard is actually 100. If you get those white baseboards, and you can see quite clearly these nice tangible tenths are in the blue, and you've got this 1 unit here that could be 100th or 1%, etc. So I'll just show that at the bottom so you can really see those relationships there between the tenth and the 100th. And again, you can pick out those equivalents. So you've got a tenths and are now 10%, and a fifth being 0.2 because you've got 2 tenths and a little tower here. And it is also known as 20% because each one part, like the orange part, the one part is 1%. So that's 20%, 20%, 20%, 20%, 20%, all makes 100%. Okay, so a really nice concrete visual way for children to make, to draw those equivalents. Alongside that, you can also plot them on a number line, which I would really highly recommend so they have that, so they have both understanding of the ordinal aspect and the quantity aspect of what a tenth is and etc. And Also, this is a good way to check their sort of understanding what would come next, what is a half as a decimal or a percentage. Lots of different questions you can ask using a number line. Okay, so here we have a series of different fractions, decimals and percentages. In year 5, you would expect the children to write percentages as fractions, and in year 6, you would associate a fraction with division and calculate fraction equivalence, recall and use equivalence between fractions, decimals and percentages. Now there's some excellent resources online to assist with this. I'll just give you a bit of a demonstration. So we've got this ITP, Maths Frame. So if I just open that up for you and just demonstrate. Yeah. So you could add another bar and then create it into 2 halves, shade and a half. And then you can reveal to the children, what is that as a fraction? It's a half. What is that as a decimal? It's 0.5. And what is it as a percentage? 50%. And also it goes into ratio, which is quite nice as well. And you can keep stacking those bars so children can see the further equivalents. So you could go into quarters, for example. Alternatively, there's another resource which is Visnos. It's the website.com, and you've got a fraction wall here. So you can kind of roll the dice, you can show or hide these and ask the children to kind of guess how much is being represented. You can also adjust it from fractions to percentages and into decimals as well. So and you can roll a dice for it to come up with just random selections which children can kind of work out what's the difference, etc. So a really nice sort of starter there to get the children thinking about fractions, decimals and percentage equivalents and what they look like in terms of in relation to each other, in terms of their value. Okay, so I'm going to leave you with these to solve. So to start off with, just a couple of hints before you begin. So when you're changing a percentage to a fraction, remember a percentage is a special fraction. It's over 100 or out of 100, so that should give you a bit of a hint. Also, fractions to percentages, 27 out of 100 is going to be your 27%. So see if you can change those denominators to make them a bit more, expand those to 100. Remember what you do to the bottom, you've got to do to the top of those fractions. Here we have decimals. So a decimal, you would just have to multiply the digits by 100. So the digit moved twice. And from percentages to decimals, you would divide by 100. And for fractions to decimals, 27 hundredths, using that language that we talked about, you should be able to identify how to write 27 hundredths using your place value knowledge. Okay, so I'll leave those with you. So please feel free to just pause for a moment, and I'll go through the answers in a second. Okay, so hopefully you've had a chance to go through those questions, and I'll just go through some of the answers together. So the first one, 17%, is 17 over 100. The next one is 78 over 100. You could have simplified it if you wanted to, but 78 over 100 is fine. That would be 48 over 100, and you can't have a decimal as a fraction, so you'd have to multiply that, so that would be 7 over 200. This one here would be 27%. This one would be 34%, because you'd have to double it, and this one would be 8%, because 25 times 4 would be 100, 2 times 4 would be 8, so 8 over, that's equivalent to 8 over 100, makes it much easier, so therefore you've got 8%. 0.15 would be 15%, 5%, 1.5%, and here would be 150%. You've got 70% to a decimal would be 0.7, 0.07, and 25% is 0.25. So from fractions to decimals, it would be 0.27, 0.34, I've got 0.08, and for 1/8, 0.125. So next steps for percentages. Once the children have really consolidated their understanding of percentages within 100 square and thought of it as half being a 0.5, etc., and divided it all up, then it's good to kind of extend the whole to maybe 200. So 2 is 1%, or extend the whole to 500. So 1% is 5. So varying the percentage of the overall amount. So by varying the numbers of squares given, children will have developed their concept of 50% of a given quantity, much like they would have done in fractions earlier on. And another great resource to get the children thinking about that is this one, which is on Top Marks. So this is so in Year 6 they will need to solve problems involving calculations of percentages, and this is a really nice sort of starter warm up to get them thinking about how they would solve that. So I'll just show you here percentage chains. Okay, so you can vary the context, which is quite nice. You've got some length, weight and money, but initially you might just want to start with numbers. So in this case I'm going to put quite a straightforward, and I'm going to put 30 in. And the whole idea is that they just need to see if they can figure out what the percentages would be if the whole was 30. So 30, then you should find 50%. 50% of 30 is equivalent to a half, so my answer would be 15. And then 10% is a really good way to start as well, and 1% because you can build up all the other fractions like that are trickier, like 2% or 99%. So 10% is the equivalent to finding 1/10. So what's my calculation? 30 divided by 10, which is 3. And then 10% converted to 20%, I merely just have to double that, so that will be 6. And then I could double that again to get 40%, to get 12. And then I could double that again to get 24. And then 1% would be 30 divided by 100, which is 0.3. And then if I want to do 99%, I could do 100% subtract 1%. Okay, should be 29.7. Okay, so lots of different ways to help the children think about percentages of amounts. Okay, and that's on Top Marks. So that's it in a nutshell, really. That's everything through Key Stage 1 and Key Stage 2 in relation to decimals and percentages. So hopefully you're feeling a little bit more confident about your subject knowledge in decimals and percentages. Hopefully you've got some idea about what misconceptions you might come across in the future when you're teaching these topics, and hopefully you've got some ideas about how you would iron out those misconceptions. Always think about relating it back to the visuals and the concrete to really help support children in their understanding of those concepts. Okay, let's move on to SATS questions now. So these are sort of the typical questions that you would get at the end of Year 6 in relation to decimals and percentages. So here's one. Here are 3 symbols. Write one symbol in each box to make the statement correct. So we've got 7/10 and 0.07. So not too tricky, 1 mark question. So all you need to do is think about whether you do your less than, greater than or equal to. So in this case, make your decision, see which one you think. And this one is 23 thousandths and 0.23. So really using that place value knowledge that we've talked about, see if you can solve either of those. Okay, and how did you get on? So this one, 7/10, is actually greater because that's 7 hundredths, and there are 10 hundredths in a tenth. So you might remember the crocodile eats the bigger number, the hungry crocodile eats the bigger number, or in mastery you sometimes see blocks here to signify that that amount is larger than the blocks that could fit in this little recess here. Okay, so you could see that the open part of that arrow corresponds to the larger value, and the narrower part of that symbol corresponds to the smaller value. So with that in mind, 23 hundredths would be larger than 23 thousandths. So yeah, not too tricky. Here's another one. This is a decimal question. So a cat sleeps for 12 hours each day. 50% of its life is spent asleep. Write the missing percentage. A koala sleeps for 18 hours each day. Write down the percentage of its life spent asleep. Okay, so I'll just leave you to have a quick go at that one. So just feel free to pause and see if you can work that out. Okay, how did you get on? So the way I solved it, but there's lots of different strategies you could use to solve it. So I thought, well, 50% is 12 hours for the cat. So that's 12 out of 24, which is 50%. And so 25% is 6 hours. And 18 is 12 hours plus 6 hours. So that would be 75%. So yes, that would be my answer for that one, 75% for the koala. And I think that's, and there's one last one. This one is slightly differs from a SATS question, and it's a mastery question at greater depth for year 6. So in a class of children, 25% are boys and the rest are girls. There are 18 girls. How many children are in the class? So feel free to pause and have a go at this question. Okay, how did you get on? So the way I would solve this is, because it says 25% of boys, then 75% must be the girls, and which is, so 75% of girls, which is 18. So this is 3/4 of the overall amount. 18 divided by 3 is 6. Therefore, a quarter, or 25%, is 6. So if we want 4/4 or 100%, we're going to have to do 4, because it's 4/4, 4 times 6 children, which gives us a total of 24 children in the class. Okay? So there's just a little bit of a taster of some of the SATS questions, some of the mastery questions that you get right at the end of year 6, drawing together everything we've talked about in terms of the rounding, the ordering, and the equivalents and percentages of amounts. So I hope that today has been useful for you in terms of picking up a bit of subject knowledge, some of the misconceptions, and how you might address them with the children with your pedagogical teaching approaches. So what I'd like you to do now is just reflect on the session, and please take with you 3 actions that you intend to take with you with the children. So it could be maybe using one of the starters that we've talked about. It could be maybe getting a resource out to teach one of the children that perhaps you've come across that's finding it a bit tricky, or perhaps maybe putting some of the visuals that we've talked about into your PowerPoint slides so that children can get a real understanding of what the place values actually mean. Okay, I hope that's been helpful, and if you have any questions at all, please do feel free to email me at kandrews@sfaet.org.uk. Thank you very much for listening.